Suppose two identical spaceships are travelling at the same speed and crash land. The first lands on its head, and the variation of force with time follows the function f1 of t equals minus 100 t squared plus 400 t for t between 4 and 0. The second lands on its feet, and the force varies as follows. f2 of t equals minus 25 over 2 t squared plus 100t for t lies between 8 and 0. The graph of force against time for the first spacecraft looks like this. The graph of force against time for the second spacecraft looks like this. Let's calculate the impulse experienced by the first spacecraft. The formula is impulse equals integral of f dt. So that's the integral of minus 100 t squared plus 400t dt, which is minus 100 t cubed divided by 3 plus 400 t squared divided by 2 between the limits of 4 and 0. So putting the numbers in, that's 100 times 4 cubed, which is 64, divided by 3, plus 400 times t squared, which is 16, divided by 2. And that's equal to minus 6,400 divided by 3, plus 6,400 divided by 2, which is equal to 6,400 times minus a third plus a half, which is 6,400 divided by 6, which is 3,200 divided by 3. What about the second identical spacecraft with identical impact velocity? What must its impulse be? Well, bringing it to a halt requires the same change in momentum, the same impulse, so it must be 3,200 divided by 3 as well. You can check this for yourself by integrating f2 with respect to time. If each spacecraft has a mass of 10, what speed were they travelling at before impact? Well, impulse equals change in momentum, so the change in velocity must be equal to the impulse divided by the mass. So that's 3,200 divided by 3 divided by 10, which equals 320 divided by 3. Finally, which spacecraft would you have preferred to be on? In other words, what's the maximum force experienced by each?